In this video, we're going to use the tapply function to create a frequency table for a numeric variable based on a set of bins that break the variable into different intervals. So this is actually a more realistic example of how you might use the tapply function in practice, and it's non-trivial, so I think it might be interesting. This is useful because plotting a frequency table actually produces a histogram, so we could use this to plot a histogram if we wanted to. We're going to use the faithful dataset and the datasets package to support this example. And that dataset summarizes the duration and waiting time between eruptions for the Old Faithful Geyser in Yellowstone National Park. So the data are a data frame with 272 observations with the variables eruptions, which is the eruption duration in minutes, and then waiting, the waiting time until next eruption in minutes. We're going to create a frequency table for the eruptions variable. For simplicity, we're going to start by extracting the eruptions variable from the faithful data frame, and we're going to assign it the name eruptions. So that's what we do in this step here. Next, we're going to use the pretty function to automatically create breakpoints for the eruptions variable. The pretty function has two arguments, x, which is a numeric object. The range of the x object is used to create the breakpoints that we're going to use. The function also takes n, which is the desired number of intervals to be created. Desired is a key word here, as this argument is often ignored by the function, though it does sort of provide it guidelines for whether the number of intervals should be many or few. What does the pretty function do? Well, the pretty function attempts to produce a set of pretty breakpoints based on x and n. And you can run $pretty in the console for more details, but this is a nice way of determining the intervals for grouping a numeric vector. So we're going to pass eruptions to the pretty function and then ask it to produce approximately 10 intervals. And so the intervals suggested by the pretty function are 1.5 to 2.5, all the way up to 5.5. So basically we start at 1.5 and then we determine the endpoints of our intervals in increments of 0.5. So we end up with 9 breakpoints, which will break our eruptions variable into 8 different intervals. So what we want to do is use the tapply function to count the number of values in each interval. But before we do that, we need to associate each eruption value with a level, so basically with an interval, based on our breakpoints. We could do this using some sort of complex loop where we iterated over each value in eruption and we determined which interval the value fell into, but instead we can use the cut function, which is a vectorized function, to do the same thing. The cut function takes two primary arguments. It takes x, which is a numeric vector that is assigned a factor label by cutting, and breaks, the breakpoints that define the intervals that cut x into different groups. So each group is going to be assigned a different label. So we're going to pass the eruptions variable to the x argument of cut, and then the breaks argument, which has the breakpoints, in the breaks argument of cut. And when we do that, each value in eruptions is going to be associated a label. So the first observation was associated the label 3.5 up to 4, the second value 1.5 up to 2, the third value 3 up to 3.5, the fourth element 2 up to 2.5, the fifth element 4.5 up to 5, the next element 2.5 up to 3, and so on. And so we can see that our points are being grouped into the different bins based on the breakpoints that we decided above. Now we can finally use the tapply function to count the number of observations falling into each one of our groups, which we call interval labels. So the eruptions are the x values applied to the tapply function. We're going to group them based on interval underscore labels, which is what we created up here. And then for each one of those groups that we created, we're simply going to tally the length or the number of observations falling into each group. So there were 55 eruptions that lasted between 1.5 and 2 minutes. There were 37 eruptions that lasted between 2 and 2.5 minutes. There were 5 eruptions that lasted between 2.5 and 3 minutes, and so on.